Alright, hello everyone. I give you some help on lesson 5.2 exercises. They're on growth and decay. Here's the page numbers. And you're going to start off with this statement that says the rate of change of n is proportional to n. Well, what that means is dn dt is equal to k times n. If you're familiar with x's and y's more, it could be written like this. It's k times y. And if we integrate both of these sides, it comes into this exponential growth formula. So that's what we're going to be talking about today. All of this, and we have on here that the c is the starting value, and this is the k is the rate. Very similar to y equals mx plus b, where you have a starting value here and a slope here. Same kind of idea, except our graphs are not going to be lines. They're going to be curves. And if k is positive, it curves up. If k is negative, it curves down. But it's the same idea here where you have a starting and a slope. Starting and a slope. Just rework differently so it makes it a curve instead of a straight line. All right, let's get right to the problems. Number 23 shows you this curve, tells you it's proportional. This is the rate, this is the formula, and it just asks you to find the formula. So we just have to find the starting value. Well, where is it up here? Where does it start at on the y-axis? And what is the rate? Well, we know it's negative because it goes down, but what negative number is it? All right, let's look at our table and see what we have. We have a 1 input, 5 output, 5 input, 2 output. Well, we don't have this starting value, so we're going to have to do some work to come up with that. And the work is to take these and plug them into this equation. So if I plug this point into this equation here, I have 5 is C, E, don't know K, but I do know 1, so I have 1K here. That's one formula, or one equation. Let's plug the second one in here. I have 2 is C, E to the 5K. And now I have a system of equations. So what do we do in algebra? Well, we solved for one of them and took it and plugged it into the other one. That's called the substitution method. So here we go. Let's solve for c in this one. Divide this over here. I have 5 divided by e to the k. I can clean that up, right? If it's in the denominator, it's just a negative variable. So now I solve for c, and I'm going to put that c in that place. So that's 2, 5e to the negative k, e to the 5k. Did a little bit of substitution, right? I took this c, plugged it in there. Those can simplify, can't they? Let's divide this over here and simplify that, e to the 4k. Just add those two variables. Now I have this situation here where I'm trying to solve for this k. It's up as an exponent. Well, we only have one step. We take the log of both sides and drops this down, and now I have the log of e. That's 1, and k is equal to ln of 2/5 divided by 4. And let's hope that's negative. Let's do this on the calculator. Log, natural log, 2/5 divided by 4, and that's my k value. It's a negative 0.2, which makes sense because it's negative means it's going down, and it's a decimal, so it's dropping, so it's going down this rate, negative 0.229. And now for my equation, I'm starting to put the pieces together, and I know what this k value is here. I'm going to erase this here, and I'm going to put in a negative 0.229. So right, this is the answer, and I can leave the x's and y's, and I know the rate right there. I don't know the starting value. Well, you can write that in your answer, but we're gonna need to do some more math with this number. So watch what I'm going to do. I'm going to hit store, and I'm going to press alpha, and I'm going to store that into the variable k. That way, anytime I need that number, I can use the k, and it will give me that number, and it won't be rounded. So try not to round. You can write your answer rounded is fine, but we're going to need do some more work with this. So store it into k so we have it. All right, well, I haven't found the starting value. Well, that's just another substitution problem, right? I'm going to take this formula, I'm going to substitute in any one of the points. Might as well use this first one right here. 5 for the y. It's equal to c, don't know, e to the negative 0.229 and plug in a 1. And if I want to find c, all I have to do is divide this whole number over to that side. So let's see here. 5 divided by e raised to the k, alpha k, times 1. And there's my c value, 6.287. All right, let's write this equation nice and neat. The equation is y is equal to 6.287 e raised to that exponent. Let me put this over here as a starting value, 6.287. And watch what I'm going to do now. I'm going to store that one. Might as well call it c. All right, so that's what you're going to be doing on most of the problems, and let's just see if it makes sense. I started at 0, which is 6.2. That's about 6. Then it dropped down to 5, then it dropped down to 2. So it's going down, so that does make sense. What you're going to be asked to do in a lot of these problems is say, well, what would it be after 10 minutes or 10 hours or 10 years? Well, you would just put a 10 there and use this equation. Let's try it. 6.287 times e raised to the negative 0.229 times 10. And we're down to 0.63. Does that make sense? Sure, it's going down, but if you have a calculator, let's try and do this a little bit more exact. Alpha c, because I had it stored in there, e raised to the alpha k, and 10. So use those letters in there so you don't have to retype everything, and so you get a more exact answer, and it just comes out a little bit more accurate. Some problems that'll make more of a difference, but you can just use those in there, use those variables in there. All right, and that's what you're going to be doing. Lots of different versions. I think this math right here is the most challenging on these problems. A lot of times you're given the initial value, so if you're given the initial value, you'll have less work. All right, let's look at one more example. 53 is about Newton's law of cooling. Kind of the same thing. The rate of change here is equal to a constant times y, but you subtract the room temperature. So what this is it's an object that's starting off here, and it cools down, right? And if there's a hot object in the room, think of a cup of coffee or something, it's going to start off at a high temperature and it's going to cool down to room temperature. See how this one is dropping down towards 0? This one is dropping down towards room temperature. And the formula is right here, and it's just pretty much the same thing, except we have an R value here and here. So on problem 53, they tell you that the room temperature is 80 degrees and the starting temperature of an object is 1500 degrees. Well, what would that equation be? Well, the equation would be y is equal to the room temperature, which is 80. And let's see here, adding on the starting temperature minus room temperature is 1420, and then we have e k to the x. And that should make sense because this object is starting at both of these put together. Now watch what happens here if I put a 0 in here. If I don't know this rate yet, so you have to do some work to find out the rate, but if I put in a 0 here, 0 times anything is 0, and I have just e to the 0, which is just 1. So by putting in a 0 here, that whole term becomes 1, and 1 times 1400 is 1400, 1 and 20. And now if you add those, you're back to the starting value. So right there's your starting value. It's just this whole thing right here, and it outputs 1500. So you can see that same starting value, you just write it a little bit different. Your math will be slightly different because of this constant out here, but all you have to do on part A is figure out the k value, and they give you 1 point. They tell you after 1 hour it is 1120, so after 1 hour it's cooled down to there. That's enough to find the k. Let's put this over here. 1120 equals 80 plus 1420 e to the 1 times k. Only have one variable. You can see the math, right? Subtract this over here, take the natural log, and you will be on your way to getting the answer there. All right, hope this helps with your work. You can graph it. Try to take advantage of using those letters on your calculator, and everything goes back to this equation, and there's some algebra involved. That's probably as hard as it gets, because a lot of times they do give you the starting value. Like this one, you have the starting value, so you could subtract this over, divide here, and you're in business. All right, hope this helps with your homework. Make sure you watch the CalcView videos. There are videos that go into more depth for problems 19 and 21 and 31. I recommend you do those ones first before starting the rest of them. Whoops, right there they are. There's videos for 19, 21, and 31. All right, have a great day.